5.11 is on word problems, real world problems, specifically dealing with projectile motion, which is like when an object, if we throw something up in the air or kick it up in the air and then gravity takes effect and it falls back down. And so these types of problems, there is some science behind it, and all of the equations follow like the same pattern. So we're taking out any wind or any other thing that would cause this object not to fall. But in these equations, the very first number, your A, is always going to be negative 16. That's where the science, it has to do with some gravity, speed, velocity stuff that I don't know. The B value is always your velocity. So you will have to know a velocity to be able to figure that out, to figure these problems out, and you'll be given that. And then the C value, the last number, is the starting height. And sometimes your object starts on the ground, so your starting height would be 0. So if it doesn't tell you otherwise, your height is 0. And so when we write these equations, we don't usually start with y equals. We actually are going to use function notation and say h of t equals. And h is going to represent the height. So all of these problems, we're figuring out the height of the object. And t is your time. So we're going to use the variable t instead of x. So it would be negative 16 t squared plus v, velocity, time, plus s, your starting height. So you're actually going to have a number in for v and s. So you're going to be asked a few different types of questions. You probably wouldn't be asked more than these. And so I'm going to go through these, and we're going to talk about like how you would find them. So we're really not learning anything new. So let me real quick sketch out a graph. Your x-axis represents the time. So, and usually it's seconds. Okay. And your y-axis, that's your height. Okay. So, where would the object generally start out at?
0 seconds,
0, 0, yep, on the ground. And then, if you were to kick it up in the air, as time goes on, what happens to the object? It goes up. Does it go up forever? What happens? It eventually will fall back down. And so it forms a parabola. So let's say like at 3 seconds, my object would be as high as it's ever going to get. It would eventually come down there. And so this is kind of what we're looking at. Let me draw that here. This is time. This is height. So one type of question that you might be asked, it might say, find the height at 4 seconds. It gives you a specific time. How would you find the height if you were given the equation? You're not going to be given a graph. If you are given the equation, how would you find the height at 4 seconds? Plug in the time. So plug in 4 seconds for the t. So, because t represents time, your h, this is your height. So you would plug in for t. what do you think when it says something about the maximum height? What part of my graph do you think it's talking about? The vertex. Good. So you will see some questions involving the maximum height. If it actually asks for the height is the y value of the vertex. So if it says, what is the maximum height? On this case, let's say this is 10. My maximum height would be 10. So it's the y value of the vertex. Sometimes it'll say, well, how long, or find the number of seconds that it takes to reach the maximum height. So we're still talking about the vertex, but if we're talking about a number of seconds, we're talking about the time, which is on the x-axis. So in that case, it would be the x value of the vertex. And then you'll be asked about when it reaches the ground. What do you think that's talking about? The time that it takes to reach the ground, but what part of my graph is that? The what? It's the x-intercepts. It's where it crosses the x-axis. So if here's your ground, there's your grass. When it hits the ground, your height is 0. So those are your x-intercepts.
Both of them or just the one?
Well, I'll talk about that in just a minute. And on our x-intercepts, sometimes factoring would work, but you're going to have a negative 16 in the front. You don't want to do that. So just use the quadratic formula. Now, when you do the quadratic formula, you have to use the plus sign and you have to use the minus sign, which means you're going to get two different answers. Sometimes your first answer would be 0 because that's where it starts out at. Okay, we don't care about that one. If you get 0, doesn't matter. Sometimes your object is not going to start on the ground. You may be standing on the top of a cliff and throw something up in the air. If that's the case, your other x-intercept would be negative. We don't care about that one either. So if you get a negative number or 0, just ignore it. And something else you're going to be really happy about is that decimals are good, are fine. Which means you can just type it all in at once instead of having to do it little piece by little piece like we did previously. So only on word problems can you do that. If I just give you a problem and I say solve with the quadratic formula, you've got to do it little piece by piece and simplify as you go. But on these word problems, you can just get decimals. That'll make it easier. So let's start. A soccer ball is kicked from the ground with an initial velocity of 90 feet per second. It's giving us the equation. H of t equals negative 16 t squared plus 90 t, that's my velocity, and then I don't have a number added because it started at the ground. Number 1 says, what is the height of the ball at 1.2 seconds? How am I going to figure this one out? Plug in 1.2 for t. Yep, I would store it because as we do some problems later, it'll make it a little faster. I'll show you. If we do 1.2 store x, and then type in negative 16x squared plus 90x. And we get 84.96 feet.
So are you only putting the right side of the equation in the calculator?
Yeah. That's just basically, I'm just saying I'm finding the height at 1.2 seconds. How long does it take for the ball to reach its maximum height? What am I needing to find here? What specifically about the vertex? The x value. It's how long, so it's asking for a time. So the x value of the vertex. What formula did we use for that? The little short formula.
Is it the one inside of the quadratic thing?
Yep.
I think it is
Start with
beautiful.
B?
No, it's negative b over 2a.
Oh.
So negative 90 over 2 times negative 16. If you type it in as an actual fraction, it's going to give you a fraction as your answer. Since when do you say that something takes 45 over 16 seconds? No. So a decimal makes more sense. 2.8 seconds, that makes more sense. So if we do 2 decimal places, it would be 2.81 seconds. What is the soccer ball's maximum height? What is that asking for? The y value of the vertex. And how do I find that?
On the x-intercept?
Nope.
Oh, right. No, that's the wrong one.
How do you find the y value of the vertex? Nope. I know the time that it takes to get there.
The x value of the
So
vertex?
I have the x value of the vertex. To find the y value, just plug this back in for t.
Oh.
So if I do 2.81 store x, I don't have to retype the equation. I can just go back up here and highlight it and hit enter. And it brings it back down. So what that means is that at 2.8 seconds, it's at its peak. And that peak is 126 feet in the air. So I don't think that a normal human being kicked this soccer ball. It was probably a robot. Because that's really tall. How long does it take the ball to reach the ground? What am I asking you to find here? The x-intercepts. And what quadratic formula? Which is negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to have that memorized for the first little part of the test. Some ways to help you memorize it is every time you're doing a quadratic formula problem, write out the formula. Also, if you go on YouTube and you search for quadratic formula Pop Goes the Weasel, there's a song in the tune of Pop Goes the Weasel, and it really gets stuck in your head. So that helps too. And then when you're asked for the formula for the vertex, there it is. When you're asked for the formula of the discriminant, there it is. So really, if you can just memorize this, you've got all three. So this would be negative 90 plus or minus square root 90 squared minus 4, negative 16. 0 is my C. All over 2 times negative 16. So I'm going to type it all in the fraction, once with the plus, once with the minus. And the first time I do it, I get 0. Well, that's the first x-intercept, and we started on the ground, so that makes sense. That's its starting point. We don't care about that one. So go back up here. You don't have to retype it. You can just scroll through, put your cursor over top of the plus, and hit the minus. And we get 5.63 seconds. Are there any questions? Number 5. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. It did not give you the equation. I want you to write the equation. So we always start with h of t. Your a value is always what? Negative 16. Then we add our velocity. What's that? 64 with the t. And then we add our starting height, which is 80. So it's negative 16t squared plus 64t plus 80. Number 6. How long does it take for the apple to reach its maximum height? What is that asking for? How long? Maximum height. X value of the vertex. What formula do I need? Negative b over 2a, which is negative 64 over 2 times negative 16. And type that in and tell me what you got. Two is correct. 2 seconds. Alright, well at 2 seconds, that's how long it takes to get there, but where does it get to? How high? What do I need to do?
Plug it in.
Plug in the 2 for t. And we get 144 feet. Number 7. What is the apple's height after 0.7 seconds? What do I do? Store the 0.7 for x, or t, whatever. So negative 16 times 0.7 squared plus 64 times 0.7 plus 80. We get almost 117 feet. Any questions? Last one is quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Alpha y equals will take me to my fraction. And I typed everything in while using a plus sign first. And that gives me negative 1, which doesn't mean anything for this problem. Okay, this is just because we were standing on a platform. So if I go back up and change it to a minus, I get 5. That's the one we need, 5 seconds. I want you to work on this last scenario, these last 5 questions, and then I'll go over them. So you can look at the answers, see if you got what I got. Are there any questions or anything that you missed, possibly that you might need me to explain? Excellent.